Imagine that one day all communication systems on Earth suddenly went silent. Phones stopped working, GPS no longer provided directions, weather forecasts ceased, and the international banking system was paralyzed. The reason is not war or a natural disaster, but an invisible enemy, millions of stray pieces orbiting the Earth. This invisible danger, known as space debris, has become one of humanity's biggest problems in space. This silent, unseen, and rapidly growing threat is actually a crisis created by humanity's own hands. The formation of space debris dates back to the early years of humanity's journey into space. This journey began in 1957 with the Soviet Union sending Sputnik 1 into orbit, and very quickly turned into fierce competition and countless launches. At first, no one foresaw that every rocket and satellite sent into space would leave a burden behind after its operational life ended. Yet today, not only old, defunct satellites, but rocket stages, fuel tanks, bolt-sized pieces, and millions of fragments left over from explosions are orbiting the Earth. According to data from the U.S. Space Force, more than 40,000 large pieces are being tracked in orbit. In addition, there are over 500,000 pieces larger than 1 centimeter, and millions of pieces in the millimeter range. Each of these small fragments, moving at speeds of up to 28,000 kilometers per hour, has the power to cause the impact of a bomb when hitting an active satellite. In 2009, the collision between the American satellite Iridium 33 and the defunct Russian-built Cosmos 2251 created thousands of fragments, revealing the severity of the problem. Similarly, in 2007, China's anti-satellite test, in which it destroyed its own satellite with a missile, generated about 3,000 new debris pieces, causing one of the greatest pollutions in space history. To grasp the risk of space debris, it's enough to consider their speed. Even a small piece of metal orbiting Earth is dozens of times faster than a bullet. NASA has to perform constant maneuvers to protect the International Space Station from these particles, and each maneuver consumes tons of fuel, meaning space debris is not only a passive threat, but also an active factor escalating costs. Looking to the future, the situation appears even more troubling. Especially low Earth orbit has started to overflow with mega-satellite constellations like SpaceX's Starlink project. Over 40,000 satellites are planned to be launched under this project alone in the coming years. This increases the possibility of the Kessler syndrome, a theory proposed in 1978 by NASA scientist Donald Kessler. A collision produces many fragments. Those fragments hit other satellites, and this chain reaction continues until orbit becomes unusable. If this syndrome occurs, a ring of debris will form around the Earth, making these orbits inaccessible for decades. What would happen if this scenario unfolds? Satellite-based internet, communication, and GPS systems would collapse. International trade would be severely hit since modern logistics depends entirely on these systems. The loss of meteorology satellites would affect many critical areas, from climate forecasts to disaster management. Air traffic control, maritime navigation, and military operations would also be at major risk. In short, space debris is not a problem that will remain in space. It is a crisis that will directly affect life on Earth. So how can this problem be tackled? Preventive measures are crucial. Designing new generation satellites to move themselves into the atmosphere after their missions, making rockets reusable, and orbit planning to reduce collision risk are among the necessary steps. SpaceX's reusable Falcon 9 rockets exhibit promising progress here. Besides, Japan's magnetic tether system aims to slow down debris and direct it into the atmosphere. The European Space Agency plans to capture and safely remove a large debris piece with its ClearSpace 1 project in 2025. Intervention solutions are also being discussed. Laser technologies may have the potential to remove small pieces from orbit. Satellites equipped with robotic arms can capture large pieces and drag them into the atmosphere. Even net systems to collect debris are being tried. However, all these technologies are costly and technically challenging. Therefore, part of the solution lies in international cooperation. Binding agreements preventing the leaving of debris in space, shared responsibility, and joint financing models must be developed. Otherwise, efforts by a single country or company will not be enough. The social and economic dimensions should not be overlooked. Daily life on Earth is tightly linked to space technologies, though most are unaware. Everything from banking to navigation, TV broadcasting to disaster management is carried out via satellites. If these systems are damaged, the global economy will suffer billions in losses. Insurance companies are already increasing premiums due to collision risks, making it harder for the space industry to remain sustainable. Space mining projects and manned missions to Mars will also be more complex and risky because of the debris threat. Considering all these factors, space debris stands out as one of the most critical problems humanity will face this century. If necessary precautions aren't taken today, Earth's orbit could become largely unusable by the 2050s. Still, there is hope. With technological progress, international cooperation, and conscious policies, the problem can be brought under control. The mistakes humanity made in the past regarding nature and the environment should not be repeated in space. The sky must be protected not only for today's needs, but also for future generations. And all these facts remind us of one thing: to protect the sky is to protect our future. What do you think about this important topic of space debris? Share your comments below. Don't forget to like the video, subscribe to my channel, and share it. Together, we can raise awareness for our future.